This is the 7.1 to 7.3 quiz review for Math 6. This PowerPoint will cover taking sentences and translating them into math problems, as well as solving one-step equations using addition, subtraction, multiplication, and division. So let's go ahead and get started. Our first slide says to write the word sentence as an equation. So this is going to be our translating part. We're going to be given a sentence and we're going to have to take that sentence and turn it into a math equation. So our first sentence says a number x decreased by 3 is 5. So when we are translating these, we need to find the word or the phrase first that tells us the operation that's happening in this problem. So for this one, it is decreased by, and that means subtraction. So underline the word or the phrase and then write the symbol above that word or phrase so we don't forget as we're translating. Then our next step is to find the word or phrase that means equals. Here, that is. So we'd replace that with an equal sign. So then if we have a number x, that's our variable, and decreased by 3 is 5, our problem would be x minus 3 equal to 5, and that would be your answer there. We don't have to solve anything yet. Our next sentence says a number a divided by 7 equals 28. So here, this one was a little bit more straightforward. Our word or phrase that gives us our operation is divided by, and that is, of course, division. And then we're also given the word equals, which we would replace with an equal sign. So with division, there's a couple ways that you can write this problem. The more common way we see normally is a division sign 7 equals 28. But as we get older into higher level math problems, that division sign starts to go away. So we can also write this in fraction form. So a over 7 is equal to 28. So either one of those works here, but both of them are division problems. And be careful because here the order does matter. Okay, a divided by 7 is not the same as 7 divided by a. Okay, we're going to keep going with these word sentences and writing them as equations. So our first one here, a number k increased by 10 is 24. Again, our first step is to find the word or phrase that tells us the operation. Here that is increased by, and increased by means addition. And then the word is going to be our equals. So our variable k is increased by 10, so k plus 10 is equal to 24. And there's our problem there. And our last word sentence says the product of 8 and a number, let's just add x in there. The number x is 66. So here product is going to be our word or phrase that tells us the operation. And that's the answer to a multiplication problem. So we know we're going to be multiplying. 8 and a number x is, again, means equals. So here the product of 8 and x. So we're going to be multiplying those together. So 8x is 66 or equal to 66. If you put a multiplication symbol in between 8 and x, that's completely fine. But please do not use the x for your multiplication sign since our variable here is x. We want to use either the multiplication dot or that little asterisk. So a times x or a and then that little star x. Those are also acceptable if we put them both equal to 66. But the best way to write it is going to be with no symbol in between at all. That still means multiplication. And we would call that number in the front of it the coefficient, kind of going back to our vocabulary in our last chapter. So let's go ahead and solve the equation. We're also going to be checking our solution. And that's kind of our plug-in step to double check that our answer actually does work. So our first problem is 7 plus k is equal to 18. So for this problem and any one-step problem, we want to make sure we draw our railroad tracks first. And what that does is it separates our left side of the equal sign or equation and the right side. So I've got two sides of my equal sign here. Because this is addition, we want to get rid of the 7. We are going to subtract 7 from both sides. Remember, think about an equation like a scale. We want to keep it equal and even. So whatever you do to one side, you have to do to the other. So I can cross off my 7s here. I'm left with just k. And then we have 18 minus 7, which gives us 11. So right now we're saying our variable k should equal 11, but we're going to make sure we're going to check that. And so we take our variable, that value we found, and plug it back into this original equation. So we have 7 plus 11 equals 18. What is 7 plus 11? That equals 18. So we know that we've gotten that problem correct. K is actually 11. Our next problem, 7.6 is equal to m minus 3.1. Again, I'm going to start by drawing my railroad tracks. So I've got the left side of my equal sign and the right side. The difference here is there are decimals, but that's no big deal. We're going to still do the same process. Here, since it's a subtraction problem, we need to use the opposite operation, the inverse operation. We're going to be adding to both sides, and we're going to add this 3.1 so we can cross it out. So we added 3.1, we can get rid of those, and we add 3.1 on the other side. So we're left with just our variable on the right side, and then 7.6 plus 3.1. When we add that up, we get 10.7 as our variable's value. And then again, we want to make sure we check it. It tells us to check our solution. So we're going to plug in the value we found for our variable. So we have 7.6 is equal to 10.7 minus 3.1. So if we were to actually do this math problem quickly, 10.7, 3.1, we get 7.6. So yes, our value is correct here. 10.7 is the value of m. Okay, our third problem is 13y is equal to 143. So again, I'm going to draw my railroad tracks. Here, there is no operation symbol, but we have this 13 right next to our variable y, and that means we are multiplying. So in order to undo multiplication, the opposite of multiplication is division. We're going to divide both sides. And in order to get y all by itself, we have to divide by 13. So we're going to divide both sides by 13 here. So 13 and 13 we can cross out. We're left with just our y. And then we take 143, divided it by 13, and you should get 11. Again, we're going to make sure that's correct by using our check step. So we're going to put that right next to our problem. 13 multiplied by 11 is equal to 143. This is one of those problems that the math fact might not be as quick. So actually taking the time to really multiply and make sure we're right is going to be very beneficial. And we do get 143. So we know that our value of y should be 11. Our next problem is 8 is equal to w over 3. This one here, our fraction is division. So in order to undo division, we need to use multiplication. So we're going to multiply both sides. And again, in order to get my variable all by itself, I'm going to multiply by 3 and cross those 2's out. I also have to multiply by 3 on the left side. So I'm left with just w on my right side, and the product of 3 and 8 is 24. And just to make sure we've gotten that correct, we're going to do our quick little check step. We've got 8 is equal to 24 over 3. So now we have to think, is 24 divided by 3 8? Yes, it is. So we know again that we are correct. W is equal to 24. Our last problem is a word problem. So first, when we're doing word problems, the best thing you can do is read through it. And then once you've read through it once, go back and reread it and underline, circle, box all the important information that you know you're going to be using. So here it says a rectangle has an area of 105 square feet. The width of the rectangle is 5 feet. Write and solve an equation that will find the length x of the rectangle. So we're going to go head back and reread the problem. It says the rectangle has an area of 105 square feet. If I see rectangle here, I'm going to draw a rectangle. And I know that the area is equal to 105 square feet. It says the width is 5 feet. So I'm going to label the width 5 feet here, and I'm going to do it on both sides. It says write and solve. So we need to write and solve an equation. We'll find the length x of the rectangle. So we don't know the length, so I'm going to label the length x, but I do know the area is equal to 105 feet squared. So I'm going to have this 105, and we're going to set it equal to what we would need to multiply in order to find our area. So the area of a rectangle, that formula is length multiplied by width. Now we are given the width here, but we don't know the length. We know the length is a variable x. So if we're multiplying length and width, and we know the width to be 5, we're going to multiply 5 and x together. Again, when they're right next to each other, that means multiplication. So there's our math problem in order to solve for the lengths. Now we actually have to solve it. So I'm going to divide both sides by 5, since this is a multiplication problem. And since we've got 5 and 5 on the right side, we can cross those off. We're just given x. And then 105 divided by 5 will give you 21. So this means that our length is 21 feet for this rectangle. This concludes the review video. Please feel free to go back and rewatch any section you need extra practice with. Make sure to study your notes from class as well as graded homework, and good luck studying.